The purpose of Lab 4.2 is to use a linear model to represent the concepts of greatest common factor and least common multiple and show how they are related. Students confuse greatest common factor and least common multiple even as adults. I also want to show you in this lab some unique ways of finding the greatest common factor and least common multiple. The typical way of finding the greatest common factor, if you remember, a factor is a number that divides into another. So if I wanted to find the greatest common factor for 12 and 18, I could list the set of factors of 12, which, remember, factors come in pairs. So 1 and 12, 2 and 6, and 3 and 4. Remember, when we are listing the set of factors, we use set braces and we use commas to separate the elements of the set. For 18, 1 and 18, 2 and 9, 3 and 6. So all we have left to try would be 4 and 5. So when we write them as pairs, always starting with 1 and the number itself, we can narrow down until we're sure that we haven't left any of the factors out. The greatest common factor is the number that is common, like 1 is common, 2 is common, 3 is common, 6 is common, and that's all. So the greatest number that would divide 12, that would also divide 18, would be 6. So this is probably how you've been taught to find the greatest common factor. Another way that is common is to do the factor tree. Where you use only prime numbers to multiply to get the factors of 12. So I could break 12 down into 3 times 4, where 3 is prime, and I'll break 4 down into 2 times 2. Break 18 down into 2 times 9, and 9 down into 3 times 3. So if I list the factors of 12 and I list the factors of 18, any factor that they share can be used one time. And so again, we find that the greatest common factor for 2 and 3 would be 6. So these are the two common methods of finding the greatest common factor. I want to show you a unique way of finding the greatest common factor. And that is, let's say we want to find the greatest common factor for 12 and 18. like we had. If I subtract 12 from 18, I get 6. So I now want to take the smallest, 12, and the difference, 6, and I'll subtract 12 from 6. I'll take the smallest, and when they are the same, you have found the greatest common factor. So this is kind of a unique method of finding the GCF, and it's very simple. Let's look at another example. Let's try to find the greatest common factor of 20 and 12. So I'm going to take 12 away from 20 and I get 8. So now I'm going to take the smaller of the two and the difference, and I'll do that again. I'll subtract. I'll take the smaller of the two and the difference. Now I'll take the difference, use the smaller of the two and the difference, and as soon as I get the same, then I know the GCF of 20 and 12 is 4. So I don't have to write out the set of factors. I don't have to do a factor tree. So this is kind of a trick method of finding the greatest common factor. The least common multiple is a number that the two given numbers will both divide into. So if I have the least common multiple for 4 and 5, I want a number that 4 will divide into evenly, that 5 will divide into evenly. Now, if these two numbers have no common factors, other than 1, we can multiply them together to get the least common multiple. Now, you may have been taught to write the set of multiples. And for small numbers, that works just fine. So if I write 4, 8, 12, 16, 20, 24 on to infinity, and I write the multiples of 5, 10, 15, 20, 25 on to infinity, the first time that they share a number, then that's the least common multiple. So the least common multiple for 4 and 5 would be 20. Alright, let's use different numbers. let's say they want you to find the least common multiple for 16 and 20. Well, 16 and 20 have common factors, so you cannot multiply 16 times 20 and get the least common multiple. You will get a number that they both will divide into, but you won't get the smallest number that they both divide into. So I would not want to count by 16s. Counting by 20s would be easy, but let's say that I do a prime factorization. So I break 16 down into 4 times 4, and I break 4 down into 2 times 2. So the prime factorization for 16 is 2 times 2 times 2 times 2. Then I do the prime factorization for 20, which is 2 times 10. For 10 is 2 times 5. So the prime factorization for 20 is 2 times 2 times 5. Now, for the greatest common factor, we pair and only use what's common. We still do that for the least common multiple. We still pair. But any factor that is left over has to also be put into the product. So 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. And 16 times 5 is 80. So the least common multiple for 16 and 20 is 80. Alright, let's say that I ask that you find the greatest common factor for 6 and 15. Now I'm going to use our shortcut method that we talked about. I'm going to subtract 6 from 15 and I get 9. So I take the smallest, and now I'm looking for the GCF of 6 and 9. So I'll subtract, and now I use 6 and 3. And now I'll subtract. I use the smallest and the difference, and as soon as they are the same, I know I've found the greatest common factor. Now, I want us to create a table, and in the table, I have the number 6 and the number 15 that we're trying to find the greatest common factor. And we found that the greatest common factor for 6 and 15 is 3. if I multiply 6 times 15, I'm going to get 90. And if I divide the greatest common factor by the product, that will give me the least common multiple. The least common multiple is A times B divided by the GCF of A, B. So I'm taking the product, 6 times 15, which is 90. I'm going to divide it by the greatest common factor, and that's going to give me the least common multiple. So that's a wonderful way of showing the relationship between the greatest common factor and the least common multiple. So let me do another example. I have to find the greatest common factor, so I'm going to use our new method. So I'm going to take the greatest common factor of 8 and 12. If I subtract, (12 minus 8 is 4, so I use the smaller and the difference. And now I'm going to subtract 4 from 8 to get 4. And when the numbers are the same, I know that is the greatest common factor. If I multiply 8 times 12, I get 96. Now to get the least common multiple, I'm going to take 96 and divide it by 4. So 24 will be the least common multiple. So 8 will divide 24 and 12 will divide 24. A factor goes into 12 and into 8. 4 goes into 8 and 4 goes into 12. That is what a factor is. A multiple is where the number 8 will go into 24 and the number 12 will go into 24 evenly. For your lab, I would like for you to use our new method that has been done in the chart, and I'd like for you to find the greatest common factor of 9 and 15 and the least common multiple of 9 and 15 using the chart like I just showed you. So I'll have you do 2 of those. The greatest common factor of 8 and 18 and the least common multiple of 8 and 18. So this is your lab 4.2 assignment that you will attach into Blackboard.